Okay, for the first video here, I'm just going to show you how to generate and interpret single sample t-test data in Jamovi. We're going to walk through the lecture example that we did, the first single sample t-test example. And just remember that we use a single sample t-test when we have a single sample mean and we want to compare that sample mean to some known population mean, some comparison population mean. And we're asking the question, is our sample mean significantly different from our comparison population mean? This is what we did with the example in lecture. Just to refresh your memory, we said we had read an article in the Globe and Mail that reported the average score on the Rosenberg self-esteem scale for Canadian university students was 29, and that it was on a 40-point scale, normally distributed. But the article didn't report the standard deviation, and that's really the key piece of information that tells us we need to use a single sample t-test because we have this is going to be our known population mean, our comparison population mean, and that population does not have a standard deviation accompanying it. Okay, so when we are comparing a sample mean to some known or expected population mean, and the population does not have a known variance or standard deviation, and we use the single sample t-test, right? Okay, so this is what we're doing. We say, we predict that Redeemer students' self-esteem will be different. We take a random sample of 5 Redeemer students, have them complete that same self-esteem scale, and we have the data presented below. We calculate the average self-esteem to be 34, and we're asking the question, is that sample mean, self-esteem, 34, significantly different than the comparison population mean of 29? All right, so these are all the steps we went through in lecture to reach our conclusion, which in the end was that self-esteem was significantly higher in the Redeemer population than in the general population with the mean of 29. So that's where we want to get to. This is how long it took us in lecture, kind of doing it by hand. Now we're going to see how quick and easy and wonderful it is to do it in Jamovi. Jamovi does all of this math for us. We just simply need to know how to interpret some of the numbers it spits out for us. Let's go grab Jamovi. And the first thing we're going to do is we're going to move the sample data into the Jamovi spreadsheet. So we are going to copy and paste this information. We have to make sure we change it to a continuous variable, and we'll call that self-esteem. And that's all we need to enter in terms of data. The next thing we're going to do is we are going to, sorry, that was just out of order there. The first thing we should do is enter the sample data, right? Now we are going to click on analyses. So in the data tab, click on analyses, and you're going to find t-tests, which are right here, and one sample t-test. Okay. So we are going to move the self-esteem variable into the dependent variables window. And there's just a few things that we need to do here now. So we need to tell Jamovi what comparison population mean that we are using to compare to our sample mean. And this is what we do in the test value. Okay, so we're entering 29 in our test value window, right? And that's because that is the comparison population mean. Or what we're doing, right? We're going to compare our sample mean to the mean of this comparison population. So you wouldn't always enter 29 in here. You would only enter 29 if that was your comparison population mean. So whatever your comparison population mean is, that's what you enter in the test value window. Okay. The other thing that you need to tell Jamovi sometimes, depending on the nature of your research hypothesis, is whether your test is a directional or non-directional test, or whether you're going to use a 1 or 2 tail test. And if your research hypothesis is directional, which direction is it in, right? Are you predicting that population 1's mean is greater than population 2's mean, or vice versa? So you have to tell Jamovi that. For what we're doing here, so let's kind of remind ourselves. Let's go back up and look at this. So we are predicting that Redeemer students' average self-esteem will be different from Canadian university students. So that is our hint that this is a non-directional test. Okay, it's a non-directional test. or it's a non-directional hypothesis rather, which means we'll have a two-tailed test. And it means that the research hypothesis is simply that our sample mean, or in other words, our mean of population 1, is just not equal to the mean of population 2, which is our test value. So if you have a non-directional test, then you can leave the default checked off. Jamovi does a two-tailed test kind of as a default, but if you have a directional test, you will have to select which of these two options you're picking, right? And I explain it here. So, right, if our hypothesis was that population mean 1 was greater than population 2's mean, you select the greater than test value. And if your hypothesis was that population 1's mean was lower than population 2's mean, then you would select the less than test value option here. Right, so pay attention to this because I believe that in your assignment you do have to do a directional test. So you'll have to decide which of these two options you check. But for the example that we're working with here, it's two-tailed, so we'll leave it at the default. What else do I want you to check off? I have asked you to check off mean difference, effect size, descriptives, and normality test. All right. Jamovi is going to give you, at that point, a whole bunch of output. Okay, it'll give you a bunch of output. And if you're really keen and interested, you will be able to kind of go and notice that a lot of the numbers that we're finding here are similar to numbers that we found, that we calculated by hand. For example, in the first table here, where we get the bulk of our information, where it says statistic, and I've annotated it with a number 1, you can go down here and read what this annotation means. And you can see that number 1 is the t-statistic. This is the sample means t-score on the comparison distribution. This is what we found out on step 4, right? So if we have a t-value of 2.94, right, that's the same as what we calculated by hand. And it tells us the same thing as we talked about in lecture, right? That tells us that our sample mean, in this case, the self-esteem mean among those in our sample, is 2.94 standard deviations above the mean on the comparison distribution. Okay, and so that's there's a lot of numbers. You can go through the output and get a sense of what these numbers are. What I really want to focus on is how do you use that output to interpret the output? How do you interpret the results of the hypothesis test? And I'm going to give you a couple of simple steps. This should really be using the output to interpret the analysis. Let's do that. All right, so the first thing that we do is we look at the sample mean, and that is annotated output number 9. So something that I'm going to do for all of these Jamovi examples is that I'll give you some example output. I will embed it in the handout, all right, and then I'm going to annotate it, okay? So what you see here, what we did is pretty much the same as what is here. And so we're just going to follow those numbers when we are interpreting the analysis. All right, so I'm going to use, I just want to show you that what I have here on the handout is the same as what I have here. It looks like the test of normality is a little bit different. An update that happened in between when I completed this and now. So we'll do that we'll kind of get to that in a minute, but I'm just going to enlarge my screen here. All right, first up, we are looking at the sample mean, annotated output number 9, and we're noting whether it was higher or lower than the mean of population 2. That's our comparison population mean. So where's our sample mean? And number 9, right? Okay, so number 9 output, mean is 34. We know that, we calculated that in class, but anyhow, Jamovi does it for us. And we're noting whether our sample mean is different, higher or lower than our comparison population mean. You can see that. Right, so here, number 5, see, this is where Jamovi reminds you that your comparison population mean is 29. So that's the first step, is just saying, okay, yeah, it looks like my sample mean is quite a bit higher than my population mean. That's good. The next thing you do is look at the p-value and compare it to the significance level. And we talked about this many weeks ago. And I said that when we do our hypothesis testing in Jamovi, all we really need to do to determine whether results are significant, right, if the sample mean is significantly different from the comparison population mean, is to look at the p-value. That's annotated output number 3. You compare it to the significance level. Remember, again, this is something that we learned a while ago, but you may have forgotten it in the meantime. If the p-value is less than the significance level, then we reject the null, and we say the difference between population means is significant. Now let's look at our p-value here. Number 3. So here's our p-value. So our p-value is 0.043. 0.043. Okay, now we have to go back and look at our significance level. Remind me of what the significance level was. What did it say? 5. So we have 5% or 0.05 significance level. Okay, so for this example, right, if our p-value is 0.043 and our significance level is 0.05, our p-value is less than the significance level. And we know that we reject the null because of that, right? So that's all we need to look at to know whether or not our research hypothesis is supported. And I want to remind you of the Spider-Men who, we said that all of these, if one of these is true, all of these must be true, right? So p is less than 0.05 and, less than your significance level. P is less than 0.05, then your results are statistically significant. The sample score exceeds the cutoff, reject the null hypothesis, right? And that's what we found in our example from lab, right? We saw that the t-score was more extreme than the cutoff. The t-score from step 4 was more extreme than the cutoff t-score from step 3. You want to see it in the picture form, right? Remember, our cutoff was the orange line. Our sample mean fell in the rejection zone. And so therefore that must also mean p was less than 0.05, statistically significant results, sample score exceeds the cutoff, and we reject the null hypothesis. Okay. One thing I should say about this mean is that in here in the example, p is less than 0.05. Remember that our alpha could also be 0.01, right? And so you have to take that into account, what your significance level is. This should maybe more accurately say p is less than the significance level. Okay, but in this example, it works out really well. And we know that we reject the null hypothesis because our p-value is less than the significance level. All right, the next thing you do is look at the effect size just to see how meaningful the difference was, right? Because we may have a finding that is statistically significant, but not all that meaningful. Now let's look at effect size. Our effect size Cohen's d is 1.31, and you can use the chart that I gave you in lecture. It's at the end of this example here, right? This is the chart that you would use to get a sense of the magnitude of a specific effect size. All right, so at Cohen's d of 1.31, that falls in the large category because it's greater than 0.80. So this means that the population means differ by 1.31 standard deviations. And we calculated that by hand here. We get the same result. It's a lot easier to do it this way. Okay. All right, the last point is we check that the assumptions are met. Okay. Assumptions. So we're going to annotate output number 7. And this is where I said it may look a little bit different. It's the thing about Jamovi that sometimes it updates. It's open source, so it updates fairly frequently. And so sometimes the version that I'm working with in the summer when I'm making these labs is not exactly the same as the version that you guys end up with when you're doing the work. So it's usually pretty similar though. So let's kind of look at this here. So test of normality. It looks like they've just added a couple of different tests of normality. So in this version, they just have the Shapiro-Wilks test. Now they have a couple of others as well. So you can just look at the Shapiro-Wilks line. to follow the instructions and interpret this. So remember, the assumptions of statistical tests are the conditions we have to assume are true in order for the math behind the hypothesis test to work properly. And the only assumption for the single sample t-test is that the distribution is a normal shape. Okay? And the really nice thing about Jamovi is that it gives you this formal test with really easy guidelines, very simple guidelines to be able to say, yes, this assumption was met, or no, this assumption was not met. Let's look at the instructions here. Normality test tells you if the assumption of normality has been met. As the note indicates, a significant p-value here, that is less than 0.05, actually indicates the assumption may have been violated. Okay, so you actually want this normality test p-value to be greater than 0.05. So let's look at this here. And so you're looking, remember, you're looking not at the statistic, you're looking at the p-value. Okay, and we see the p-value for our Shapiro-Wilks test is 0.362, which is greater than 0.05, which is what we want, right? We want a non-significant value here. We want a p-value greater than 0.05. That tells us that the assumption has likely been met. Okay. And I believe that's all for this video. Just a word about the second video. It's just a review of the information regarding why we can just use the p-value to interpret results of a hypothesis test. So there's not a handout here. It just provides you with the opportunity to just remind yourself of some of the things that we talked about, almost a month ago in lecture now, of again, how kind of the p-value maps onto thinking about the critical or the cutoff value and the significance level. And so that's all that is. It's not too long. So I'll see you back here for video 3.